Section 3.4 talks about polynomial functions, graphs, applications, and models. So one of the first things we're going to talk about today is the concept of the end behavior of a polynomial function, okay? So what we have here is we have when the degree is even. What do I mean by that? Remember, the degree of the polynomial is going to be the power, okay? So that means that the degree is going to be even. So we'll be looking at x squareds, x to the fourth, x to the sixth, x to the 124, right? Something like that. The highest power is going to be even. Okay, so we have this information here in this kind of graph of whatever you want to call it. I'd like to sort of make a chart, okay? So I'm going to make a little chart. It's going to look something like this, and we're going to say what happens when n is even, and we're going to say what happens when n is odd, and then we're going to figure out what happens when my leading coefficient, oops, let's see if I can make this a little bit better. I'll tell you what, we'll do it over here. What happens when my leading coefficient is positive, and what happens when my leading coefficient is negative? Okay, so what we have here is we have our even degree, okay, right here. When the coefficient is positive, the graph is going to be up to the left and up to the right. What we mean by that is as we go further to the right, the graph is going up. As we go further to the left, the graph is going up, okay? And what happens when the coefficient happens to be negative? As I go to the left, the graph is going down, and as I go to the right, the graph is going down. So it's going to be down left and down right, okay? Now, what happens when our exponent is odd? Okay, when the exponent is odd and my coefficient is positive, as I go to the right, my graph is going up, so up to the right. But as I go to the left, the graph is going down. So I'll tell you, why don't we put the left first, since that's what we were doing. So we'll go down left and up right. Okay. And when my coefficient is negative, as I go to the left, my graph is going up, so up left. And as I go to the right, my graph is going down, so down right. Okay. Now the reason why I like to kind of put it in this kind of a chart is it says use the end behavior diagram. So I'm going to be choosing from these options here to describe the end behavior graph of each polynomial function. Okay, so the first thing we're going to do is we're going to look at the leading coefficient. The leading coefficient is the one that has the highest degree, the highest exponent, okay? It won't always be the first one, but usually it is, okay? But we're looking for the highest power. So the highest power we have, the leading term, is 5x to the fifth. So the first thing I want to look at is I want to look at my exponent. My exponent is odd. The second thing we're going to look at is we're going to look at, oh, come on, pen, there we go. We're going to look at our leading coefficient. Our leading coefficient is positive, right? It's positive 5. So when we're positive and we're odd, the graph is going to go down to the left and up to the right, right? So I'm going to be choosing one of these options here, okay? So there's down to the left and up to the right. Okay. So let's see if we can do the same thing for the next one here. So the next one, my leading coefficient, or my leading term, negative x to the third. So our exponent is odd, because it's 3. The leading coefficient is negative. So when it is odd and negative, we're going to be going up to the left and down to the right. Okay. All right, let's take a look-see at the next one. Again, my leading coefficient here, 10x to the, or my leading term, I'm sorry, 10x to the 6. So first thing is my exponent is even, and my coefficient, the number 10, is positive. So when we're even and we're positive, we're going to be going up to the left and up to the right. Okay? And if I look at the last one, again, remember what I said, the leading coefficient or the leading term is the one that has the highest exponent. I said usually it's going to be the first term, but not always. So if you notice here, now we have a negative 10x to the fourth. My exponent is still even, but our coefficient is negative, right? So it's going to be going down to the left and down to the right. So when you're doing your problems like this in your homework, y'all, these are the choices that you're going to have. And you'll choose one of these. And again, the way you'll figure that out is by looking at that little chart right there, okay? So I like to write it that way. I just think it makes it a little bit easier to understand. All right. So now we're going to talk a little bit about graphs. And it says the graphs in figure 25 suggest that for every polynomial function f of odd degree, there's at least one real value of x such that f of x equals 0. All that means is that there's going to be at least one x-intercept. Okay, that's what that means right here. This sort of sentence, put a square around it or block it in. This right here just means that we're going to have at least one x-intercept. The real zeros correspond, there we go, to the x-intercepts of the graph and can be determined by the factored form of each polynomial. So you can see we're looking at our x-intercepts. There's 1, 2, 3. There's one right here, there's one right here, and there's one right here. Okay? Now, one of the things I want to point out is when I'm looking at my x-intercepts, okay? When I'm looking at my x-intercepts, when the graph just kind of crosses through and crosses like that and then kind of comes back up, each of these x-intercepts occur once, okay? Occurs one time. Same thing here. This thing just kind of passes right through, it occurs once. If you look at this one, I'm going to try to zoom in. It's probably going to throw me off a little bit, but we'll come back and find it. Let's see. Yeah, it threw us off, but that's okay. We'll come back. Let's see if we can find it. Here we go. It didn't throw us off too much. Let's see. Where are we? Okay, so let me get my pen again. So do you see here how it kind of flattens out like that? When it flattens out, when we kind of have that flattening part, it's going to occur an odd number of times, but it's usually going to be 3. And the more flat it becomes, then it would be like to the 5th power or to the 7th power. So what I mean by the degree, look at the x-intercept right here at -2. Okay, I know we have a positive 2 there, but all that means is that x plus 2 is equal to 0. So the 0 is -2, okay? Since it flattens out, but it doesn't flatten out too much, that one occurs 3 times. When my x-intercept hits and bounces off, it's going to occur an even number of times. And if you notice here, it occurs twice, okay? It occurs 2 times. Now, there'll be times when it's going to kind of even out, and when it evens out and it kind of flattens out, like if it kind of does that number, then we would say it's probably going to occur 4 times or maybe 6 times or maybe 8 times. The more flat it becomes, the higher my power is, and they're going to be even, okay? So let's take a look over here. If you look at these, they just cross. So we have 4 x-intercepts, and they all occur once. Let's see, this one occurs once, right? How this one bounces off, it occurs twice. And how this one kind of flattens out a little bit, it occurs 3 times, okay? So that's what we're looking at when we're trying to figure out how many times are these things going to occur. So I'm going to try to walk you through this process a little bit more so that we can kind of get an idea of what's going on, okay? But I'm just trying to give you like a preview. Okay, so it says find a polynomial function of least degree having the graph shown. Okay, so the first thing we're going to do here is we're going to say, let's look at our x-intercepts. One of them is x equals -6. One of them is x equals 2. One of them is x equals 5. So when I have my x-intercepts, now what I can do is I can write my factors. I'm going to bring each of these numbers over to the other side. What I mean by the other side, I'm going to write like this: x plus 6, x minus 2, x minus 5. They would all be equal to, when I move them over, there's nothing on the other side, they would be equal to 0, right? Okay, so now we're going to write out our polynomial. It's going to look like this: f of x equals. Now, I don't know what my leading coefficient is. There could be a number here. It doesn't necessarily need to be 1. It could be 5. It could be 8. It could be -2. I'm not certain what it's going to be. Okay, so, excuse me, I'm going to write that as my an, and we're going to have x plus 6, x minus 2, and x minus 5. Now, if you notice, we do have another point here. We have that point 0, 30. Remember, the 0 refers to the x, and the 30 refers to the y. So what we're going to do now is I'm going to come back over here. Remember, my f of x is the same thing as my y. I'm going to leave my an number alone because I don't know what it's going to be. And everywhere I have an x, I'm now going to put my number, I'm now going to put my number 0. Okay. So let's see, that's 6 minus 2 minus 5. So 6 times, well, let's multiply these first together because that's going to give me 10. So this is going to give me 60 an, and we can divide both sides by 60. And so my an is going to be the number 1/2. Okay. All right. So now, now what I'm going to do is let's write it out. F of x equals 1/2. We have x plus 6, x minus 2, x minus 5. And I want to say it's probably going to ask you to write it out like the whole thing. Multiply it and everything. Okay, so we can do that. That's no big deal. Let me leave this x plus 6 alone. All right, so that's going to give me x squared minus 5x minus 2x plus 10. Okay. So f of x is 1/2 x plus 6. This is x squared minus 7x plus 10. Okay. So now let's start to distribute a little bit. Let me move this guy. Let me move this guy over a little bit. There we go. Okay, so let's take the x first. So that's going to be x to the third minus 7x squared plus 10x. And then let's do the 6. So plus 6x squared. Let's see, minus 42x plus 60. Okay. So f of x equals 1/2 x to the third. Let's see, minus 7x squared and plus 6x squared is a minus x squared. Plus 10 minus 42 is a minus 32x. And then we still have a plus 60. So the next thing I'm going to do, I'm going to go ahead and distribute my 1/2. So we're going to have 1/2 x to the third minus 1/2 x squared. Half of 32 is 16, and half of 60 is 30. Okay. So I want you to look at my polynomial. We multiplied the whole thing out, right? Look at our leading term. Our leading term is a positive 1/2 x to the third, right? So let me come back here. Let me scroll up just un poquito. We came up with f of x for the leading term to be 1/2 x to the third. So first thing I want you to notice, my exponent is odd, and my coefficient is positive, right? Look at the graph. It's down to the left and up to the right, right? So if I were to come back to my little chart that we had all the way up here, here we go. And let me move this over so we can see it. And it's right here. When it's odd and it's positive, our graph is down to the left and up to the right. And that's exactly what we came up with when we did our problem here, right? So all that tells me is that I'm coming up with an answer that's making sense, okay? I'm coming up with an answer that's making sense, all right? All right, so let's see if we can do the same thing here for this one, okay? So first thing we're going to do, we're going to write out our x-intercepts, okay, just so we know. So the first one is x equals -5. The second one is x is equal to 3, but I want you to notice how the graph hits it and bounces off. This one is going to occur twice, right? When it hits and bounces off, it's going to occur 2 times. So now I'm going to write out my factors. When I bring that 5 over, that's going to become an x plus 5. When I bring that 3 over, it's going to become an x minus 3, and we said we're going to have 2 of them, right? So now we're going to say f of x is equal to whatever my a number is, right? X plus 5 and x minus 3 squared. And we have another point here. We have that point, 0, 9. Remember, that's my x and that's my y. So that 9 is going to be for the y. X is going to be 0. And we're going to solve for a. Okay. So let's see. 9 equals a. 0 plus 5 is 5. 0 minus 3 is a -3 squared. Okay. This is still 5. -3 squared is 9. So 9 equals 5 times 9 is 45 with an a. So we'll divide both sides by 45. And a is coming up to be 1 over 5. Okay. So now I'll write it out. F of x equals 1 over 5. X plus 5 times x minus 3 squared. And I'm going to leave this one like this. Guys, if it does ask you to multiply it out, then go ahead and multiply it out, okay? Same thing with the one we did before. If it did, I'm not certain if it's going to ask you to multiply the whole thing out. If it does not ask you to multiply the whole thing out, then we could just stop right there, okay? But if it does ask you to multiply the whole thing out, then we got to go all the way to that part, okay? All right. So now, let's take a look at this next one here. I'm going to go about it exactly the same way. First thing we're going to do, we're going to find our x-intercepts. Okay? So the first one we have is x is equal to -3, x is equal to +3, but I want you to notice, they hit the graph and they bounce off. They hit the graph and they bounce off. So each of these here are going to occur twice. Okay? So that means the factors that I have are x plus 3 squared, because there's 2 of them, x minus 3 squared, because there's 2 of them. So then when we start to write this thing out, it's going to look like this. X plus 3 squared, x minus 3 squared. Okay? And my point right here is the point 0 and 81. Okay? So remember, this is my x and this is my y. Okay? So 81 is equal to a. 0 plus 3 squared, 0 minus 3 squared. Okay. So 0 plus 3 is 3 squared. 0 minus 3 is a -3 squared. Okay. 3 squared is 9. -3 squared is also 9. So 81 equals 81 with an a. So when we divide both sides by 81, we come up with a is equal to 1. So now all I'm going to do is I'm just going to write it out. F of x equals, you can put the 1, you don't have to, because remember when you put the 1 right here, it's going to be the same thing. X plus 3 squared times x minus 3 squared. Again, if it asks you to multiply it out, just take your time. Do the full method twice, and you'll get there, okay? And that right there, guys, was 3.4.